Okay, hello everyone, good afternoon. Hope you've all been having a good day. I'm Wael, and I work as a principal security engineer. I lead the security engineering and operations team at Medallia. I work out of Palo Alto, and there's a disclaimer, the usual disclaimer that all of these opinions and the work done here does not represent my employer, or is not related to my employer in any shape or form.
I'm Sar. I'm the hardware and software deployment manager at MIT. And my interest in this has been, my whole career was spent in education. So I have been in higher education throughout. And I don't know if some of you know, I think a lot of you are from the Boston area, I'd imagine. And so edX offices are right down the street. And edX naturally has been a big buzz around campus for, 4 or 5 years now at least. Somewhere around there. So anyone who's interested in anything would have heard about edX, the future of education, MOOCs, all this stuff. So that was kind of a personal interest of mine of getting involved in, given that I do work in higher education, just to see what the future might hold. And both Wael and I have been super interested in getting more involved with Python and coding and that kind of stuff. So that was a perfect opportunity to learn more of that.
Okay. So I'm actually a network engineer that eventually started doing security. So not really doing any full stack development. So if you're wondering how I ended up here, sometime last year, a friend of ours had an LMS related problem to solve, and we were looking for a problem to solve, not necessarily with LMSs, but we said, okay, this sounds something interesting. And after, doing a survey of the market, we're like, okay, OpenEdX really looks like something interesting that might do the work for us here. So that's when we started looking into it. That's how I kind of got involved with it.
And I think just as a side note too, and this is more personal for me than anyone else, Wael and I have actually been best friends for about 30 years now. And we met in school, so doing something educational and something that might influence the future generation and how they might meet, whether it's online or in person. That's definitely something that is a big interest of ours, and that was kind of one of the driving forces behind us getting involved with the community and the platform itself.
So, we initially, we liked what we saw a lot, but then as we started to dig deeper, we realized, okay, but running an actual, production grade service is a different matter. And so my background is, whether it was at Medallia or previously at Cisco, is running large scale distributed networks for production. I've been out of the enterprise network space for a while, so everything I either deploy or troubleshoot or design networks for was, production based. So briefly, what we would like to cover today is a little bit of our journey of how we got here, how we the thought process that we went along with to get to what we know, and some unfortunate and sometimes frequent encounters with a familiar sinking ship. Anyone? Maybe just us? Okay, that's fine. Actually, quick show of hands. Who has mainly deployed the full stack instance? Okay. All right, I think we're done here, since I'm assuming you've all done the distributed one then. Actually, who is running a distributed one in production? Okay. And who has just deployed one for, fun or got bored? Okay, cool. So we're going to talk about some issues we faced along the way based on various deployment topologies. So we've tried pretty much everything. Yes, and so we have select components that we chose to sort of deep dive or just talk about and focus, and we'll justify why we decided to talk about what we did.
So yeah, I think the big thing for us was it's more about the journey and just some of the lessons learned, because I think the challenge for us was we looked at the full stack, but we also wanted to do a distributed environment to try to understand the different components and how they all communicate with one another, and that was kind of part of the journey, and that's what we'll be discussing. And I think some of the stuff some of the pictures you're definitely going to recognize, because I'm sure everyone who's in this room has dealt with a lot of this stuff.
Yeah, so one thing along this journey I would always be asking myself, like, I really would love to know if anyone else has gone through this or, you know, is losing their hair like me or so anyway. So we're going to talk about how Open edX is perceived by various parties. So, you know, the view that the end user is familiar with is, you know, this, super friendly, pretty, inviting, all of those good things. And at one point, that was up. So that's, you know, from an architectural standpoint.
How many of you, how many of you have actually spent some time looking at this and trying to figure things out? Oh, okay. I actually ended up printing this out and have it sitting over my desk, and every once in a while I just keep looking at it, trying to figure things out. But I think because of this talk and preparing for this talk, all of this makes a lot more sense. So we're hoping that after this, maybe some of those pieces that might not have made sense to you before do make sense after this.
I'll have to admit, I did not initially share his sentiments because, like I said, I've been designing, you know, distributed networks, and so he had some of those concerns. I was like, oh, that looks fairly standard, right? But again, this was before we tried implementing anything. And there's more accurate pictures of what I looked like later. So, and then as an implementer, the resolution here doesn't really, I don't know if you folks can tell what this is, but
so this is all the Ansible playbook roles on edX's configuration GitHub repo. And again, everyone's familiar with all this stuff. This is nothing new, but that was one of the things we started looking at after the previous diagram and figuring out, okay, now we want to roll out our own. How do we do this? And so we started here.
So yeah, so, you know, user, architect, implementer, someone dabbling with AWS. I don't know if this looks familiar. Well, this is as close as a baseline production topology would look like. And then in the real world, this is a dreaded failed Ansible run. And the thing is, usually this doesn't like happen just in the first 5 minutes and then you fix it and you're done. Like this could be like 4 hours into it and then you get this. And you're like, okay. So then you hit this. And eventually, that's what you sort of end up doing.
So far we got to the point where we tried to looking at the cloud formation. This is something that was on the repo, but I know in one of the comments or one of the documentations they said this is not maintained, but we gave it a shot and we finally managed to get the AWS cloud formation working. But again, it still didn't make a whole lot of sense. We had a lot of things going all over the map and we just wanted to pull our hair. But what we ended up finally getting to, which I think everyone managed at some point, was we went ahead and got the full stack up and running, and that was a really good day.
So, you know, we called it the all-in-one wonder. It's a lifesaver because it mostly works when you get a clean run. And I would say if you're doing things right, it does work. And however, it comes with, you know, pros and cons. Pros is the convenience of having this all-in-one that you just run and magically everything is laid out for you and it works. And you get that pretty login screen and most of the functions do work. However, if you do want to dig deeper, it's an all-in-one. So just if you're not very familiar already with what's under the hood, trying to disentangle all the flows and the calls and having everything co-located in one location makes it a little hard, right?
And I think as nice as it is to have an automated deployment where you just run the playbooks or download the Vagrant box and have it up and running, it feels like a black box. And we wanted to know, and even though it is open source and everything's out there, but still you not having to install and configure stuff, at least from my standpoint, it still felt like a black box and we wanted to get a better picture of what's running on it.
So this was fine, like we said, until and you know, all along we knew that like this has all sorts of warning stickers, right? Not for production. So we were aware of that. The intention was not to run it in production. So to revisit the distributed deployment, we decided to, you know, make sure we're actually intimate with the fundamentals there. And that's sort of something I do in my day job. I always try to go back to first principles, especially when I'm handed an application that I meant a threat model with very little documentation. I mean, that's just kind of standard. So I just go back and say, okay, how does this thing work? And obviously, in that scenario, I'm dissecting it for other reasons. But in this case, it was like, okay, I really need to understand this thing if I'm going to, whatever, try to sell it or tell someone how it works or even try to keep it up.
And we both have computer science background, so I think everyone who's been in that program knows divide and conquer is the way to go. So we just wanted to split up the components and start understanding each one and what it talks to and how it talks to it.
Some of the useful things we came across, this is a more recent diagram of the architecture or some of the components. It's a high level, but it's hardly the Rosetta Stone that a clueless duo. I mean, not entirely clueless, but clueless in the way that we would have wanted to sort of be more knowledgeable. So, any comments on that? And that's pretty much what we ended up doing, is reversing anything that we came across and we felt that the documentation was not there for.
So how many people, just a quick show of hands too, how many people have actually tried to reverse engineer and kind of split up the components and do that whole setup on their own? Cool.
Okay. So we took a multi-pronged approach based on the fact that we did try both, the distributed as well as the all-in-one. So, so the route we took from the single box install was to break that down and figure out what were the minimum components really needed to deliver the core service. Of course, it's a very subjective definition. Some people might consider certain components to be core, but we'll just say what it is that we thought was core, and we sort of simplified it down to that. And in parallel, we also did some efforts to understand the distributed topology better than our initial understanding, and also do a little bit of customization. So when we started playing around with the CloudFormation template, it has certain settings the way it is. So part of that process was to say, okay, I actually don't want it to be laid out this way. I need to change that. And when doing that, things broke. And as part of fixing it, we gained new understanding of also what the challenges are in running in a distributed fashion are.
Because I think one of the big problems when you look at some of the visuals from the Open edX team, it doesn't split up the components by the different names. So yes, I'm familiar with Nginx, I'm familiar with RabbitMQ, MongoDB, but when you're looking at a lot of the stuff, it doesn't specify what that piece is and where it falls in that picture. And so the one thing we did want to get to is, let's get those pieces and let's figure out how they're configured.
Okay. So some things that are, at everyone's disposal, just digging through code for things that relate to the problem at hand. Logs, this general, sysadmin goodness. Sysdig is really handy. It's a tool I've used before, but not as much as when I was actually trying to work on this. And I sort of found it really analogous to just doing snort or TCP dump from, when doing network-based stuff. This was completely indispensable, especially when you have the all-in-one single box install and you're trying to disentangle all those streams. So getting really familiar with what filters you need to, again, reminds me of like setting up your Wireshark filters, if any of you do a lot of captures and that kind of analysis.
Yeah, I wasn't familiar with Sysdig before, but working with Wael, we actually started learning some of this stuff, and it's extremely helpful. It does have its own syntax naturally, but it's something you can easily pick up on, and it's very helpful in tracing a lot of the stuff. And as far as Slack, everyone, I'd imagine, if you're not using Slack or checking out the Open edX Slack channels, I strongly recommend that. It's been extremely helpful, and a huge thanks to all the folks that maintain this stuff and moderate it, because I don't post a whole lot, but just going in and reading some of the stuff in the channels, seeing what everyone's dealing with and having to resolve is a huge benefit. So I do recommend it.
So we made some progress, and part of that was just being able to actually redraw what it is that we were perceiving to be that platform, right? In the beginning, it was this nice high-level architecture diagram, but we couldn't really relate it to anything else that we knew. So this was one, and this is an interesting look at the
So with this, what we ended up doing was there was a cool tool, and I think it was called Ansible Genome.
Yeah,
so it runs through your Ansible playbooks, and it kind of comes up and figures out what dependencies the different roles have. Because that was one thing we were trying. So Wael was focusing a bit on the infrastructure side and AWS stuff, and I was trying to get a better grasp of Ansible and the playbooks and how they all interconnect and what goes first and which role should we install first or last. So this kind of gives you a good idea. And as you can see, common is definitely one that a lot of pieces hook up to. Supervisor is another one. NLTK has a bit of dependencies. But common is, as expected, the bigger one of all of them.
So, you know, I find this stuff fascinating because it's one thing to just scroll through pages of roles, but then to also be able to visualize what's actually happening under the hood when you start provisioning stuff. And, you know, the magic of programmatic infrastructure is, yes, with a couple of clicks, you can stand up an entire data center. But it's when something goes wrong that you realize, okay, now I do have that complexity under the hood. And things like that, I feel, really help you get your head around, okay, what is at play here, and how do these things sort of mesh together? And you know, sometimes just having these different slices of that reality really help in understanding the full picture. But you know what? Something was still amiss. We felt that we could still simplify a little further. We didn't think we got to that, you know, sweet spot we wanted. And so we realized we could simplify stuff further, and we experimented with some more deployment topologies.
And I think after we looked at the Ansible playbooks too, the one thing I was trying to do is, I noticed there are some packages installed that didn't feel like, I wouldn't call necessary, at least if we're trying to do stuff in a production environment. So we started cleaning up some of the Ansible playbooks just to keep it to a bare minimum so that we can go to AWS and run a distributed setup there with the least amount of stuff to get things up and running.
So our focus was not least common denominator. It was really to maximize our understanding and also be mindful of, okay, if I did want to run this in our cloud, would I want this? Would I want X, Y, or Z? So obviously that's, you know, take that with a grain of salt. It's a subjective thing, and it depends on your goals, right? And so we ended up abstracting the architecture down to those components that we thought were really essential. So, you know, driven by less is more, we sort of got to this. And so I'm typically an infrastructure person. And most of the times I need to know how a packet left a user's browser and what sorts of what sort of chain reaction it caused once it got to my network, and what resources it touched. And you know, and to do that, you need to be able to trace that path. And all the other stuff that I found publicly didn't quite tell me that story, right? So that whether it was the architecture diagram or looking at the roles or any of that stuff, it didn't tell me that. And it really starts with, you know, that front door here, right? Do you have any other comments before I get into that?
No, and the one thing was we kind of had, this is a bit of our interpretation of how things are actually set up. So in here you see the app, and in the full stack or in real life, a lot of those pieces are together, but this is kind of how we envision it. So this is just our interpretation of things, and I think I just wanted to make that a bit clear.
Yeah, like for example, someone might consider, you know, Unicorn part of this because it essentially does that WSGI heavy lifting, and the core app or business logic lies here. We did want to separate it because when you look at if you're tracing the calls or the network flow, there is a distinction. So like I said, it's that infrastructure-centric view where I can actually say, yes, there's connections that terminate here, and this proxies another connection here, and this does a whole bunch of other stuff there that I can actually observe, right? So that kind of informed the choices. Now, as for the components, so with Nginx, Gunicorn, Rabbit. So this is the collection of, this literally the Django code.
Those are all the Django apps.
As well as the Ruby.
And there's another Ruby app that's still being used for the discussion forums that uses the Sinatra framework, I believe.
And on the far left, it's really back-end, so MySQL, Mongo, and Memcache, although Memcache is back-end-ish. So, all right. So, Nginx, front door, provides proxied and load-balanced access to static and dynamic assets. One thing I would have loved to have when I first started was like a pointer to things like, okay, if you're troubleshooting this, go look at this log file. And they do exist in many places. But for convenience sake, for example, again, putting my network hat on, knowing what the listeners were. Now, of course, again, you can go and analyze the site configs on your own. You'll get those. But just sort of teasing that stuff up to the top, I figured was helpful for me to sort of understand how everything was laid out.
And the big thing with Nginx is when you provision it, it does have 4 different or 5 different sites. You have LMS, CMS, XQ, and Forum, and certs. If I'm not mistaken, and don't hold that against me, I think certs are turned off by default, but that's something you have to go into Django apps and turn it on. So I don't believe we saw it listening on that port, but the configuration showed that that's where it should be listening on.
Yeah, there wasn't an upstream configured. Another thing I found was there was a version site that did not have an upstream, and
the edX release, I think, I believe it was a site that's created, but yeah, we couldn't find anything on it. And
yeah, and the file isn't there, so the file it's looking to serve wasn't there. So, and blowing that up further, focusing on this a little bit, just showing the mappings to Gunicorn. So, static assets Nginx would serve up on its own. By the way, again, this all has to do with how you decide to co-locate those components, right? If, depending on the scale you want and the topology you have, this could be separate or it could be co-located with like an edX app node. It really depends on how you deploy them. This was the setup we chose to have just to sort of show the different interactions. And so yeah, front door 80, 18010, and for XQ, and that's what they map to in Gunicorn. And Gunicorn's calling the business logic for each one of those. For Forum, there's a domain socket. And for example, I don't know if that's because it's an all-in-one, but definitely that would change if you're doing the blown-up distributed version, right? You have any comments on that? No? So a little bit more stuff on Gunicorn. We'll talk about that.
So with Gunicorn, and again, this is something I was not familiar with, but thanks to this presentation, this is stuff I learned, was the call would typically go from Nginx, and if it's looking for any static assets, Nginx would respond to that and not have to go anywhere else. And it does filtering based on the URL, I believe, but if it does not find those static assets or it doesn't need any static assets and it's actually a call for some Django thing, it would go to Gunicorn, and then that would transfer it over to the Open edX app, which is running all the Django apps.
So depending on how far along you are, so things like the number of workers you have for each of those things, absolutely important for scaling. So probably if you're doing all-in-one or maybe even a minimal distributed deployment, you're probably not thinking about them until you perhaps encounter a performance issue. So knowing what those are by default, as well as how you might want to scale them, especially, they obviously have cost considerations. So knowing what those bottlenecks are and the relative ease or difficulty if scaling that component is, I think paramount if you're doing any production kind of deployment. More pointers to logs here. And you'll notice that by default, LMS is 8 workers, 4 for CMS and 4 for XQ. Okay.
Here's the big one. To us, the biggest thing has been the config files, and those are what really do everything, mainly in the edX app. If you want to change any configurations, that's typically where you go. And if you've seen any of the Ansible playbooks, they do recommend if you want to override anything, you actually use the server vars.yaml file to basically override some of this stuff. And again, it's mainly CMS and LMS configurations. We also came up with the bar chart that shows you all the accounts that do get provisioned when the Ansible run goes. If you didn't get the syncing ship or no failures in your Ansible runs, and typically you don't. Those are all the accounts. I believe there's 17 of them. But the edX app is mainly it has all the Django apps. I mean, it's built mainly on Django apps. There is the one thing we did mention is the Ruby component to it, and I think the one thing I did come across was there was maybe some thinking about moving that a Django app, but I'm not sure. Maybe Ned hopefully is working on that at some point, but we'll see.
So a different view of the package situation.
And the other thing we ended up trying to figure out is, so if you've been through the Ansible run, the two places that it feels like it's taking forever and you start wondering whether it actually crashed or disconnected, there's something happened, is when it starts installing the different applications and when it does the database migrations. So we wanted to get a clear picture of what are all the different packages that make up the edX app.
So this is base requirements? Is it?
This is the base requirements, and this is pretty much the biggest one. I think it has 50% of all the packages. And here is the GitHub requirements file, and that's another huge one. And naturally, edX app is in the middle with all those connections.
By the way, this is heavily prettified. The first one wouldn't fit here, and then we had to make a judgment call on like overlaying the actual labels with something else that could be visible, and even then it's not so visible. So, okay. So Rabbit, it's this thing that you'll never think about as long as it's working, and you will really be thinking about it if it's not working. You'll also be thinking about it if it's undergoing performance issues. So even though not everything goes through it, it's mainly reserved for large jobs that need to be queued and coordinated by Celery. It is nevertheless, I think, a crucial component, and I think of it as one of those supporting infrastructure components that need to be there. It should definitely be well-resourced and supported so it doesn't turn into a hidden single point of failure. I've seen many agile environments where, people sort of worry about the front door, making sure that's horizontally scalable and all that, and then they have issues and they're like, oh, it's Rabbit. We did not think about Rabbit. So not saying that's the case, but again, it depends on how you deploy things, but I do worry about message queues and making sure they're well-resourced. So again, yeah.
The thing we missed, and we'll probably add it at some point down the line, is we didn't talk a bit about the exchanges, how many exchanges and how many queues and how many accounts Rabbit does, but we actually have that information, so that'll be something we'll add here. But I think there were 7 or 9 exchanges that it does create. Just can't remember.
And as with all the other components, we're listing out the listeners. It kind of helps. You're looking at your connections table to know what is what and getting familiar with that. Again, location of logs. Moving on to memcached. So it's a high-speed key value store used for caching a whole bunch of stuff. The things we know of and we've seen is user session info as well as course information. Placement here would obviously be relatively subjective. It's usually very close to what's being served out. And again, it's mentioned here because it's one of those infrastructure components that you will run into if you're tracing the path of traffic. Yeah, that's really how we ended up saying, oh, well, we need to talk about this because I see traffic ending up there. However, these components will probably not cover every function by the platform. we do think they cover most. And from a learning standpoint, I think they do the job.
So with Mongo, we do have 4 DBs, 7 collections. It is being used to store the courses and the forum discussions. And again, it's a core component, just like MySQL, maybe even more. It's easy to scale, and that's definitely something, depending on how many courses you have, that's going to be something you're going to have to look at from very early start.
Okay.
Last but not least, SQL. So we did want to have a nice graph for SQL, but again, as I mentioned earlier, was one of when the Ansible playbook runs, the one that feels like it's taking forever is the migrating stuff, and it actually does create 278 tables in the edX app database, and that's exactly why it takes a while. Again, this stores authentication, authorization data, and it does have the analytics stuff in it. And it does create, I believe it creates 17 different accounts, naturally with different configurations to the different databases and tables and such.
Yeah, so for each one of those components, we're trying to sort of tease out relevant data, whether it was, okay, tables created, or how many accounts, or how many workers are they running, just to get a sense of each one of those components, and the sort of environmental sizing you might want to think about when deploying them. Okay. And finally, last thoughts. So for us, this is just a start, and we're aware we use more of an infrastructure-centric lens, hence why we ended up with this kind of analysis and this choice of components. The next thing we'd love to do is to turn that towards the application layer. So, and in fact, some of those components that we had, we did not dig as deep as we would like to. So that is the next thing we're going to do. So that application-centric exercise is definitely in the works, and you know, we'd love to hear from you regarding this talk or anything else edX related for that matter.
So the one thing we will be working on is we're going to try and create out of some of the slides and some of the stuff we actually found out about the different ports and different configurations. We will have a cheat sheet where you can easily reference, because I think that was super helpful when we were working on stuff the last few weeks, so we would love to share that with everyone. And if anyone wants, and we'll continue actually trying to clean up some of the Ansible playbooks, and once we have those, we will definitely share that with everyone. And if you have any requests or anything you'd like us to share or any questions, again, please feel free to reach out. And another shout out to the Slack channels. Do take the time to join them if you're not there, because it's a huge help for everyone. And thank you for coming. And does anyone have any questions?
How do you test your deployment after you deploy all this distributed stuff? How do you make sure that all the connections are right?
So the one thing we did start doing was we started with the different pieces. So we would, let's say we set up MySQL, and then the next role was, I believe, Mongo, and then we did edX app. We just, initially for now, we started doing some basic things. So if you have Mongo, we should be able to log in, create a course, and do that. The other thing I know everyone knows it who deals with this stuff, logs, look at your logs. The one thing I ran into was, I would be so convinced that it's in, say it's a MySQL error maybe, and I would think it's somewhere in the MySQL log, but it actually ended up being maybe a Mongo error. So I kind of tried to get in the habit of making sure to pretty much look at all the logs, because I didn't have a clear picture of who's talking to what. But I think after some of this work, we definitely have a huge or a clearer picture of where we should be looking and what we should be looking at.
So we sort of ended up with an unwritten playbook of the steps we follow after deploying. one thing that's definitely on our table is to automate a lot of this stuff, because we follow the same stuff, even not just for testing, but as we were trying to figure out what is talking to what, there's a lot of manual work we were doing that we think we can automate and to make those, to connect the dots in an automated fashion. It's absolutely doable. So it was partly following some of that, that playbook that we, converged to, as well as just being proactive about, hey, does anything look out of whack? Are there any, log entries that seem ominous? And yeah, that was pretty much it.
Two questions actually. First, did I miss something, or did you not talk about Elasticsearch? And then, when you try to plug a sentry, in our experience, it really helps with debugging.
We spent like 10 minutes on Elasticsearch. Were you? No, I'm kidding. We didn't talk about Elasticsearch. No, we did not talk about it, yes.
Oh.
Yeah. Did not.
Okay, so in our experience, Elasticsearch is like the most difficult component because it breaks down pretty well.
ES is a complicated beast, it's true. But for most of the things that we were trying to test or sort of be clear on, we frankly did not hit ES. And it may simply be our choice of things to look out for. So we're kind of aware of that possibility, yeah. We'll probably look at it next.
And did you consider Sentry for error reporting? Sentry is a Python application.
I'm not familiar with it. Are you?
I'm not.
No, don't know it. Okay, we'll look into it. Thank you. It's to catch errors in Python execute.
All the logs.
And exceptions, and you can view the stack trace.
Oh, okay, cool. Thank you.
Anything else? Awesome. Well, thank you for coming. I hope you had a good day.
Thank you.
A great conference.
Thank you.